Okay, welcome. So we are still on applying second law of thermodynamics to solving problems. Let's consider the question on the board. It says an engine which has a maximum efficiency of 30% produces 10 kilowatts. Question says estimate the heat received and the heat rejected by the engine per minute. All right, so let's get down the parameters I was given. We have that an engine which has a maximum efficiency. So efficiency, okay, was given to us as 30%, and this is actually what 0.3 simply by dividing by 100, that gives you 0.3. Produces 10 kilowatts. So power produced, or power, simply power P equals 10 kilowatts. Okay, question says estimate the heat received and heat rejected. Of course, I've explained the heat engine. I explained the heat engine when we talked about heat being transferred from a high temperature reservoir, okay, down to a system through a low temperature reservoir first before work is being done on the surroundings. So what is coming into the system is simply what heat received, that's Q1, and what is being rejected there is actually heat rejected, which is actually what Q2. So this is a good example of the heat engine. Okay, this is temperature T1 and this temperature T2. This is source and this is sink. So what comes into this system, okay, what comes here, the heat that comes here is actually heat received, and heat that goes into the cold temperature reservoir is actually the what heat rejected, which is Q2. So the question is asking us to find the heat received and the heat rejected. So simply we are looking for heat received, unknown, which is Q1, unknown, then heat rejected, which is Q2, is also unknown. Okay, heat received by the engine per minute. So we're giving time. Time is actually 1 minute. Time T is actually 1 minute. And 1 minute is equivalent to simply saying 60 seconds. Okay, 1 minute is also 60 seconds. All right, so when we did the heat engine, I simply said that the efficiency of a heat engine is actually what? The work done all over heat supplied. And the work done is actually the change in what? The heat from the inlet or heat received minus the heat rejected. That gives us the work done. So we simply have Q1 minus Q2. This is the work done all over the heat supplied or heat received, which is simply Q1 all over Q1. So this is actually a formula for efficiency. And this is what we have been asked to find: heat supplied and heat rejected. Efficiency was given to us simply as 30%, which is 0.3. So this actually implies that 0.3 is actually equal to Q1 minus Q2 all over Q1. So then again, 0.3 is simply saying 0.3 divides by 1. So you can easily cross multiply. The whole of this top multiplies 1. 0.3 multiplies Q1. So we're simply going to have, let's do that here. Okay, so we're simply going to have Q1 times 0.3 simply gives us 0.3 Q1, and this is now equal to, here I'm left with Q1 minus Q2 multiplied by 1. It still gives us Q1 minus Q2. Okay, so since I have 0.3 Q1 here and I have Q1 here, let's bring them together. So I simply have here 0.3 Q1 minus, of course, this is positive here, so positive sign crosses an equal sign becomes negative. So bring Q1 here, you simply have minus Q1, and that's equal to minus Q2. Here I'm left with minus Q2, and of course 0.3 Q1 minus Q1 actually gives us minus 0.7 Q1, and this is equal to minus Q2. So from here, negative sign can actually cancel negative sign. So you simply have that Q2 is actually equal to 0.7 Q1. Call this equation 1. Let's keep that equation apart, okay? Now, we are also given power as 10 kilowatts, and this power was actually in a time of what? 1 minute, which is actually 60 seconds. So recall that power itself, power P, is actually what? Work done all over time. This actually gives us power, the work done over the time. And we know what the work done is in terms of heat engine. The work done in heat engine is simply difference between what? The respective heats, the inlet heat and the outlet heat. So simply Q1 minus Q2. This is what gives us the work done. The time was given as 60 seconds. So it actually means here that P, which is power, is actually what? In place of work done, we have Q1 minus Q2 all over. The time given was 60 seconds, so simply all over 60. This gives us the work done, and this gives us the power. And we know the value for the power. Power is simply 10 kilowatts, so we can convert that. Of course, 10 kilowatt is simply 10 by 10 to the power of 3 in watts. So we can simply convert that. So 10 kilowatt is simply 10 by 10 to the power of 3, and this is equal to work done Q1 minus Q2 all over 60. So we have this. Once again, 10 by 10 to the power of 3 can also be likened to be 10 by 10 to the power of 3 all over 1. It's still the same thing. Any variable or any value divided by 1 still remains that same value. Now it becomes easier for us to cross multiply. This multiplies the whole of this. 1 multiplies Q1 minus Q2, and then I have 60 multiplying 10 to the power of 10 by 10 to the power of 3. So I will simply have this to be 60 multiplies 10 by 10 to the power of 3, and that's equal to 1 multiplies Q1 minus Q2 still remains Q1 minus Q2. Okay, so from here 60 by 10 to the power of 3 simply gives us 60 by 10 to the power of 4, okay, equal to Q1 minus Q2. Call this equation 2. So we simply call that equation 2. Now, recalling from equation 1, we had that Q2 equals 0.7 Q1. So which means we can simply substitute that in place of Q2 into equation 2. Okay, so substitute 1 into 2. Okay, into equation 2. If we do that, we'll simply have 60 by 10 to the power of 4. 60 by 10 to the power of 4 to be equal to, we have here Q1 minus, in place of Q2 actually give us 0.7 Q1. So we simply have here 0.7 Q1. Okay, so 60 by 10 to the power of 4 is now equal to, this will simply give us 0.3 Q1. So we simply make Q1 subject by dividing through simply by 0.3. So this implies that the heat supplied, which is Q1, is actually 60 by 10 to the power of 4 divides 0.3. Okay, therefore Q1 is equal to, so you have simply 200 by 10 to the power of 4, by 10 to the power of 4 in joules. Okay, in joules. So you have this to be the heat supplied, and if you know Q1, we can simply find Q2 from equation 1. So substitute into 1, Q1 into equation 1, and from equation 1 we have that Q2 is actually equal to 0.7 Q1. So that's simply 0.7. 0.7 multiplies Q1 is simply 200 by 10 to the power of 4. So which means Q2 is equal to 140. 140 by 10 to the power of 4 in joules. So these are the values of the heat supplied and the heat rejected by the engine. Alright guys, I hope you find this video interesting. Please, if you do, don't forget to share your thoughts in the comment section, and of course, if you're new to the channel, please tap the subscribe button to keep getting updates on content such as this. I will see you in the next video with more amazing questions on application of the heat engine from second law of thermodynamics. Thanks.